Hi and welcome back. Second part of trigonometric functions. Okay, let's go over what we were doing happening before. Doing happening. That sounds really funny. Okay, the first thing that we did was list all 6 trigonometric functions, and we said we're just going to focus on the first 2. All of the other 4 are going to perfectly fall into place once you have been able to learn the first 2. We defined a trigonometric circle right here, which is a circle of radio equals 1. And that radio equals 1 we're going to call h, the hypotenuse of a triangle that is formed inside the circle. Okay? The hypotenuse is the distance between the center and any other point in the circle. That distance is 1. Okay? The angle that the hypotenuse forms with the x-axis is called alpha. Okay? And that alpha is going to be the argument for the trigonometric functions. The adjacent side of alpha we're going to call x, which is this distance right here. It's on the x-axis. Okay, so we're going to call it x. And x in a triangle of an angle alpha is going to be cos of alpha. Okay, the adjacent side. You should have learned that in high school probably. Okay, and the opposite side, the side of the triangle that is in front of alpha, we're going to call y. Okay, and y is sin of alpha. Okay, this alpha is this alpha right here. Okay? Then that, we define the equation for the circle, which is x squared plus y squared equals 1, because 1 is a radio. And all we do right here is replace x by cos, following this, and y by sin, following this. Okay? And this is the identity function. Okay? Now you see where it comes from. So what's going to happen next? Well, what we're going to do is find out the values of sin and cos as we move along the trigonometric circle, okay? And what I'm going to do is that I'm going to, let me erase this for a second. I'll write it up a little bit upwards. What we're going to do is that I'm going to draw the triangle here. Just magnified, okay? I should have done it in green instead, just to remain consistent. Okay, this is alpha, and this distance right here at the bottom is x, which is cos of alpha. This distance right here in front is y, which is sin of alpha. Okay? Now, this triangle is this exact triangle. I just magnified it, okay? This right here is still h, and h equals 1, hypotenuse. Okay? And this point is a random point in the circle, which we're going to call xy. Okay, it has coordinates x, y. So what we're going to do is move along the trigonometric circle to calculate the values of x and y. Okay? Let's start with, let's suppose the following. Let's suppose for an instance that this h equals 1 is right here. Alpha is 0, okay? If h is right here, alpha is 0. There is no triangle. Okay, let's start right there. Okay, if h is all the way here, there is no angle. Alpha is 0. Okay, so if alpha is 0, and we're going to write that right here. This is alpha. If alpha is 0, alpha is 0. It's right here. What is x? What is the distance between here and here? Okay? If the hypotenuse is here, well, that means that this triangle is all the way down here. This triangle is all the way down here. This distance has moved all the way across the trigonometric circle. Okay? And the distance from here to here is 1, because that's the radio of the circle. Okay? So x is going to be 1. Okay? If h is here, all across this line, what is y? What is the height? Well, there is no height because I am in point 1, 0. Okay? If h is right here leaning, leaning across the x-axis, h is leaning across the axis, there is no height. Okay? Because it's just right there in the axis. So the height is 0. Y is 0. Okay? Now, let's suppose we have an angle. Let's say alpha is 30 degrees. Okay? Here, you can bring up your calculator and help up a little bit with the calculation, okay? Because I'm not going to go over the whole thing, but you're going to get pretty much what's going on, okay? If alpha is 30 degrees, then we have a triangle defined just like this, okay? We're going to have a hypotenuse, an x, and a y. And if alpha is 30 degrees, well then something magically is going to happen. X is going to have a distance. It's going to be less than 1 because by that point, x has moved a little bit more to the left. And y is going to have a value greater than 0 than the past value because there's going to be some height. Okay? There's going to be some height. Now, what is that distance? Well, you can do two things. You can either calculate it by using the laws of cos and sin in triangles with one angle, or you can just do it in the calculator. Sin of 30 is going to be 1/2. This distance is going to be 1/2, and this distance, x, is going to be square root of 3 over 2. Okay? Again, you can verify this both in your calculator or just operating a triangle with an angle and a given side. Okay? Now, what happens if alpha is 60 degrees? Okay? Again, if alpha is 60 degrees, well, x becomes even shorter. Okay? X becomes even shorter. And y keeps growing. Okay? The degree of the triangle is, becoming, the height of the triangle is becoming bigger. Okay? We can even redraw it and do it like this. Okay? H is still 1, that's for sure. But y and x, they're changing. And the triangle is going to look a little bit like this instead. Okay? So as you can see, x gets smaller and y gets bigger. Okay? This alpha 60 degrees is going to be, x is going to be 1/2, and y is going to be square root of 3 over 2. Okay? What happens if alpha is 45 degrees? Okay? Well, in that case, x is going to get a little bit bigger and y a little bit smaller. Okay, we can redraw it. It's going to look a little bit like this, probably. Okay? And in that case, cos is going to be square root of 2 over 2. And sin is also going to be square root of 2 over 2. Finally, 90 degrees. What happens if alpha is 90 degrees? Well, if alpha is 90 degrees, then h is all the way here. It's vertical. There is no x. Okay? If alpha is 90 degrees, then x has disappeared. H is going to be across the y-axis, like this. Okay? It's just going to be a straight vertical line. Okay? You're going to have something like this. Boom. Because the degree is 90. And if the degree is 90, well, x, what is this distance? X. It's 0 because you're right here across the y-axis. Okay? And y, on the other hand, it's equal to the hypotenuse, meaning it's 1. Okay? So cos of 90 is 0, while sin of 90 is 1. Okay? there you go. We have been able to come up with the basic values for sin and cos using the trigonometric circle. Okay? So how is that going to help with these functions, with the remaining four? Well, everything else falls into place. Why? Because of the following. Let's see, how can I write this? I think I'm going to erase the trigonometric solver for 1 second, okay? Okay. Tangent is sin over cos. So let's say you want to find the tangent of 60 degrees. Well, just do sin over cos. Square root of 3 over 2 over 1/2, and that's it. Okay? Let's say you want to find tangent of 0. We'll just do sin over cos. 0 over 1, 0. Tangent of 0 is 0. Okay? Cotangent, let's change the color, is cos over sin. So it's, again, the same thing. The only difference is that it's, upside down. Let's say you want the cotangent of 30 degrees. We'll do cos over sin, which is square root of 3 over 1/2. Okay? Let's say you want sec. Well, in that case, sec is 1 over cos. Okay? And if you want cosec, well, in that case, it's 1 over sin. Okay? And all these properties you should have learned either in high school or before your college class. Okay? So I'm assuming that you should know them. Okay? But in essence, like I said, just by knowing these two, you can know all of these. So what's going to happen next? We're going to use this table and this knowledge to do the graphs of the trigonometric function. Okay? I know it's a lot of content, but hopefully you'll be able to understand. Okay? See you in the next video.